Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called path with maximum gold. So in this problem we have been given a grid of size m by n. Each cell in this mine or in this grid, so here grid represents the mine, gold mine, right? And this grid has an integer representing the amount of gold in that cell, right? If 0 it means it is empty. We can move all the four directions. So that's what they mentioned here, left, right, up or down. Every time you are located in a cell, you can collect all the gold in that cell, right? So we can collect all that amount that is there in that cell, right? Never visit the cell with the 0, right? You can't visit the cell more than once. All right, you can start and stop collecting gold from any position in the grid that has some gold. All right, let's quickly check the constraints. What are the constraints here? So length will not never be 0 because it is greater than equal to 1, and the value would be between 0 and 100. There are at most 25 cells. All right, let's quickly jump to the whiteboard and let's try to understand this problem, right? So this is the grid, this is given grid. Now let's see here. So very first item is 0, so we cannot visit 0. We will skip this. Now let's start our search from 6, right? So 6 is there. Now we have four options. We can either go left, right, up or down, right? So let's say this is left, this is right, this is up, and this is down. All right, so left and right, they are 0, so we cannot visit those. Now there is another option is down. We cannot go left because it will be we cannot cross the boundary of the matrix or grid, right? So that's why we cannot go up. We will go down. We will see, okay, this 8 is there, it means it's not 0, we can still visit that. So we will accumulate 6 plus 8, right? Now we will have again three options, right? Why I'm saying three options? Because 6 we already covered, so we will not go back, right? So now three options, we can either go left. So let's see, let's go left, right? So now left. Now what is the addition, what is the sum of these numbers? 6, 8, 14 and plus 5, 19, right? So 19 is the number, right? So now we cover basically this path, 6, 5, 8. Now we don't know, right? We don't know whether it's a maximum or not, so we will have one variable that's called max that will keep a track of the maximum value or maximum amount, right? And from that maximum amount we will compare this 19 whether it's 19 is the maximum or not. So let's say for example this 19 is the current max. All right, now from 5 we will go back to again 8 to explore the other remaining directions. So we went back to 8 and now the remaining direction is 7 and 9, right? So let's go ahead and accumulate 7 as well. 6 plus 8 plus 7. What is the addition here? 6, 8, 14 and plus 7, 21. So 21 is greater than 19. So our current max would be 21 now. Let's go back from 7 to 8 again to explore the remaining direction, that is 9, right? So it would be 6 plus 8 plus 9. So this is the remaining cell that we did not visit it earlier, right? So 6 plus 8 is 14 and plus 9 is 13. So now we got 13. That is the current max because 23 is greater than 21, right? It's not 13, it's 23. All right, now we visit all these directions and we started our journey from 6. Now let's start our journey from 5, right? So let's say we are having now bunch of other paths here, but I think the idea should be clear, right? So we can either go 5 plus 8 plus 7 this route, and then from 7 we can again go back to 8 to traverse through another path that is 5, 8, 6. So basically there will be bunch of other paths here as well. 5 plus 8 plus 7, 5 plus, oops, there is a typo here, 5 plus 8 plus 6, right? And then 5 plus 8 plus 9, that will also be the another possible sum. And let's calculate here. So 5 plus 8 is 13 plus 7, 20, right? That is less than 23, so our still max is 23. 5 plus 8 is 13 and plus 6, 19, that is still less than 23. 5 plus 8 is 13 and 9 is 22, right? That is still less than 23, so we still have 23 as the maximum. Similarly, we will keep traversing each and every path, right? So we started from 5 now, and then let's go ahead Now let's start from 8. I choose here the blue color to differentiate. So from 8, basically we have now couple of options. If we start from 8, we can go either 5. So 5 plus 8, this is one path. 8 plus 7, this is another path. 8 plus 6, this is another path. 8 plus 9 is another path, right? So certainly they are not going to be greater than the current 23. So I'm not going to write it here. Now another thing, we can start from 7 as well. So 5, 8, 7. So we can let's move to here. So if we start from 7, we can have like multiple paths, right? This is one path, 7, 8, 5, right? So 7, 8, 5, right? Another path would be 7, 8, 6, right? So 7 plus 8 plus 6, this is another possible path. 7, 8, 9, this is another possible path. 7 plus 8 plus 9. So let's sum up these guys. 7, 8, 15 plus 5, 20. 7, 8, 15 plus 6, 21. 7, 8, 15 plus 9, 24. So we got 24, that is greater than 23. That was earlier value we got here, right? So 24 is greater than 23. All right. Similarly, we can start from 9 and we can just go up all the way up. So the another path would be like 9 plus 8 plus 6, right? And this is again basically 23. 9, 8, 17 plus 6, 23. 9, 8, 7, we can have this path as well, right? And this path we already covered, like 7, 8, 9 or 9, 8, 7. That's like, that will give us the result as a 24. Similarly, we can have 9, 8, 5 as well. That will also give the result as a 5, 8, 9 itself, right? So the uh, idea here is basically start traversing this grid, because it is a two-dimensional matrix. So definitely we will need two for loop. From that two for loop, we will start our journey wherever we find non-zero. So we will start from that cell that is not zero. Once we start from that cell, then we need to go all the four directions, because we have been given in the problem itself that we can go only four directions. So we will go to the four directions, left, right, up and down. We will take care of the base conditions as well. Once we hit the base condition, that it means we can just calculate the maximum at that time, right? It sounds little different strategy, but in this case we need to count the max. I think it's little convenient to count the maximum at the time of the base condition, means at the time of once we hit the base condition in the recursion, right? So we are definitely here going to follow the depth first search strategy, and we can use recursion. So depth first search, why we are using? Because we are going deep in any direction, right? So if we are going left, we just keep going to the left until we hit the base condition, then we are recursing back, and then we are exploring another direction. And then once we hit the base condition, then we are again coming back from that direction, and we are again traversing to the next available direction, right? So left, right, up and down, these are the four directions we are going to explore in this particular problem, right? So I hope the high level design should be clear. Let's quickly jump and create couple of placeholders here, and then I think picture might be a little bit more clear. So let's say I took like int m, that is the length. So grid dot length, it means basically the what is the length, and then so this is like height and width, right? So when I say grid dot length, that is the height, and n grid 0, so what is the column length, like the first column, that will be considered as a width, right? So now we are having the height and width, right? Now as I mentioned, we will need two for loops. So let's go ahead and use these two for loops here. So integer j equals to 0, j is less than n, and then j plus plus, right? And let's take another variable here, and that's called max gold. And why I'm taking this as a integer array, there is another option, I can take it as a global variable as well, but I wanted to avoid that. That's why I'm taking this as a array, so that in my helper method I can just keep updating this, right? If it is a not an array or not an object, then my helper method will not be able to update the value of this, right? So it should be either object or an array. So let's say I'm having a method that's called set max gold amount, right? So I'm passing here grade ij, and then let's say I'm passing this max gold as well to update the maximum gold amount. And let's say I'm having 0, that is for the current sum. So I can accumulate these sum and then I can keep comparing with the maximum amount, right? So max gold 0. All right, now let's quickly create this method as well. Set max gold amount. So let's say the first parameter is grid itself, second is row, and then column, and then max gold, and then I'm having this sum. All right, now let's take care of the base conditions, right? So row is less than 0, row is greater than grid dot length minus 1, right? Or column is less than 0, or column is greater than grid 0 dot, so grid 0 dot length minus 1, or so this is like pretty standard template to check the boundary conditions, right? The base condition. All right, now let's check if it is 0 or not, right? If it is 0, then we also want to get out from the recursion, right? It should hit the base condition and it should basically go ahead and return from here so that we don't hit the stack overflow error. All right, so quickly here we can calculate max gold, right? So here, and why we are calculating here, so once we hit the base condition at any point of the time, let's say we started from here 6 8 9, and 9, from 9 we cannot go anywhere, right? We cannot go left, we cannot go right, we cannot go out of boundary, so it will hit the base condition. At that time we will accumulate this sum. So this 6 plus 8 is 14 plus 9 23, so we will record this 23, right? Next time we will have another variable. Let's say if we are following this part, 6 plus 8 14 plus 7 21, then we will compare, okay, what was our earlier 23 and this is the current 21, and what is the maximum 23, so we will record 23. So that's the idea. Once we hit the base condition, we want to keep recording that max gold. All right, because we are here using grid row column as a 0, so we can mark it as a visited with the help of 0. So we don't need to carry, or we don't need to maintain the additional boolean array to mark it as a visited, because the thumb rule in the depth first search or breadth first search to keep marking the cell as a visited, so we don't visit the one cell again and again. And they explicitly mention here as well in the third point that you cannot visit the same cell more than once. All right, so now we need to move all the 4 directions, right? So one option is we can just call this method 4 times for the 4 directions, and another option is basically we can just take 2-dimensional array, right? And this 2-dimensional arrays will have the coordinates, and then with the help of those coordinates we can just move all the 4 directions. So let's say if I am taking all these 4 coordinates here, 0 minus 1 1 comma 0 minus 1 comma 0, I mean anyways fine. So whatever convenient is for you, let's go ahead and follow that thing. This time I'm using this thing to avoid those 4 lines. So int direction, so this will have the each cell, right? So 0 1 and 0 minus 1. I hope this is clear. So let's say this is the thing here, right? So these are all the directions. So 0 0 is this middle point. Whenever we are moving to the right side, it means we are moving 1 comma 0. Whenever we are moving to the left side, it means it is the negative minus 1 0. When we are moving to the upside, that is 0 comma 1. Whenever we are moving to the downside, it is 0 comma minus 1. So that's how we are going through left, right, up and down, and then we just keep adding our x and y coordinates. That's how we can keep moving, right? Another option is we can do row plus 1 for up direction, row minus 1 for the down direction. So it's the same thing. Let's go ahead and call this method set max gold amount grid row plus dir 0. What is dir 0? That is the x coordinate. Dir 1, this is y coordinate, and again max gold sum. And one thing I also forget here, to accumulate, right, to calculate the sum as well. So let's go ahead and do the sum part. So sum plus equals to well, right? So well is this the current amount, right? So now the use of this well is, once we will go back from 9 to 8, right? Let's say we are following this path 6 8 9, and we reach to the hit the base condition. From 9 we just want to roll back our value, right? So 9 we just mark it as a visited. Let's go ahead. Okay, so I don't have any other page, but what I mean to say is, whenever we will be visiting all these cells, right, let me quickly do the control Z so that I will have the fresh page here. So what I'm saying, like, once we will visit this 6th cell, we will mark it as a 0. We will mark it as a 0, right? 0, 8 also we will mark it as a 0. 9 also we will mark it as a 0. But 9 we just follow this path, and then from 0 we will again roll back to the 9. So why? Because we will go back again to the 8, right? And from 8 we can just follow another route as well. So for 8 also we will roll back our value. Earlier we mark it as a visited, it means we marked it as a 0, and then from 0 we will rolling back to the previous value, that is 8. And with the help of 8 we can just traverse other directions. So let's say if we are traversing through this direction, then it would be 6 plus 8 plus 7, and it will again mark it as a 0, and then we will again roll back this to 7, 0 to 7 again, right? So 7 to 0 is to mark it as a visited, and from 0 to the previous value to mark it as a unvisited, so that we can just explore the next available direction. So I hope this is clear, and that's why what we need to do here, grid row column, we will be doing well, and that will make sure that we are rolling back to the previous value to backtrack, right? This is also called as a backtracking. So this is the high level design. Let's quickly check what we did. So we are having m and n max gold, right? This is keeping track of the max gold, and we are returning once we calculate the max gold. This method is calculating the max gold for us. So this max gold, we are keeping taking care of the base conditions. We are recording the current value. We are just accumulating that sum, the current value. We are marking it as a visited. We are moving all the 4 directions, and we are rolling back basically for the exploration of the next available direction. So this should be it, right? Quickly, the time complexity wise, basically we are just traversing through this whole matrix, and let's say it is m and n, m by n matrix. So in the worst case, basically we will end up to traversing 4 directions, right? So it will be like 4 to the power m into n, right? And the space complexity, in the worst case, we can just go m by n times, so it is m by n itself. So that's why it is m by n, right? In the implicit stack, it might consume the whole matrix size, so it is m by n. That's why. Let's quickly check for the compilation error. So here we need to compare against the sum, right? So max gold 0. All right, so now let's check. Looks like this is compiling fine, right? Let's quickly check and try to submit. So this is working fine as expected. So quickly, very quick summary before ending this video. This is the problem of basically depth first search problem, where we have been given a grid and we need to find the maximum amount, right? And another observation we can think, we cannot take here the variable and then we cannot calculate the max every time and then we can calculate the max here, right? The reason we cannot do that, because we need to do the backtracking. So backtracking we can have only in this helper method, right? We can have only in this helper method, that backtracking we can have. And after, in the backtracking, in that process, once we hit the base condition, then we need to keep a track of the maximum amount as well. And that's the reason we cannot have the variable here and then every time we just pass row and column and then we just keep a track of max. So we cannot calculate the max in the outer for loops, but we need to keep a track of the max and we need to calculate the maximum amount in the base condition itself. So that is uh, basically, I will say little basically to understand, this is the thing that we need to understand in this problem, right? Another, as I mentioned, like another approach might be rather than taking all these directions, we can just quickly do this 4 times, right? So as I mentioned earlier, whatever feel comfortable, we can take that route, right? So row, column, and then we can repeat this line 4 times as well, 2 3 4, right? So that will also serve the same purpose. Row minus 1, then this column plus 1. Column plus 1 is right side, column minus 1 is the left side. So this should also produce the same result. And let's go ahead and submit this one as well. So this is also working fine, right? So anything is working fine, whatever you feel comfortable, this then we can comment this guy, we don't need this guy as well, right? So uh, quick summary was, this is the grid, m by n grid. We need to calculate the maximum gold amount. So we need to understand the fact that we can start and stop at any cell, right? And that is the important point here to consider. So we will keep passing this I and j, and it will keep changing. This I and j will keep changing in this outer two nested for loops, right? Once we pass this row and column, corresponding row and column, we will be keep accumulating with the help of variable sum, right? And we will keep marking it as a visited as well, because 0 is empty cell, so we can use that fact and then we can assign this as a 0 once, and then that 0 we can use it as a visited. Once we hit the 0, it means it is a visited, and then we can calculate the maximum gold. After traversing one particular path, as I mentioned here, we need to change back that visited thing to the previous value, and that's why we are just doing this thing, grid row column to well, so that we are just roll backing to the previous value, so that we can just explore the next available direction, right? And that sum also we can accumulate, and then we can just compare against the new sum as well. So that's the reason we are doing the backtracking. Hopefully this makes sense, and if it is too much complicated, or if you have any feedback or question or doubt, then just feel free to comment out and just please let me know. Thanks a lot. Have a good one. Bye.